Henry Gross is in the construction business. He's not your typical hard hat, though. He's a master at a rare specialty, raising the roof. He's been doing it for 25 years.
That's a sweep. Sweep your nuts.
Today, he's trying to make this old building new.
It's backbreaking. It's hard work.
He's converting this vertically challenged low-rise building into a warehouse. That means lifting its 317-ton roof nearly 5 meters in the air.
Roof lifting is a process of hydraulic lifting that applies to typically older buildings with low ceiling height. And we come in and we raise the existing roof of the building to any height required.
The first stage is undressing the building, gutting the insides.
This particular building, we've stripped the existing building back to the bare bones to enable us to fully do a 70,000 square foot lift.
Before the lift begins, a temporary support system is put in place. It becomes the shoulders that the roof will sit on once it's separated from the building.
This is a hydraulic lifting system made up of 2-foot steel sections. Our patented system is bolted together to basically replace the existing column that you see beside each crib post.
Almost 100 yellow crib posts are needed to support the weight of the roof during the lift. Each one can hold up 25,000 tons. First they're assembled, then they're welded near the roof, bolted at the floor, and a series of guy wires are added for safety.
When everything is in place, we cut the columns. In all the locations you see where we have the crib posts, all the columns will be cut at the same time. We will separate the whole building from the perimeter.
In some spots, the roof has to be physically separated from the walls. Leaving even the smallest piece of steel attached could compromise the entire lift. Finally, the lift begins, except it's almost impossible to detect until daylight begins seeping through the cracks.
What we're doing is we're picking up the west side of the roof, a ½ inch, and then we bring the east side up to that ½ inch and progress another ½ inch. And then we just drop back and forth on it to monitor the roof. You really don't want to lift it real fast because you want to be able to watch what it's doing at all times.
Progress is slow, just ½ a foot every hour.
That's a sweep and a reset. We'll have to tune it as we go.
The lift is controlled by the synchronization system.
It monitors the lift and it tells you what each and every crib post is doing at all times, how fast it's lifting, how far it's lifted, and it just gives you complete control over the roof.
Flexible steel tape connects it to each crib post like strings on a puppet.
And it's attached to the crib post. As it lifts, it pulls the tape with it. On the other end of the tape, we have our sensor boxes and we have elastic bands to hold tension on the tape. And they're tied into these synchronization boxes. We can lift 6 at a time, we can lift 1 at a time, or we can lift them all at a time.
As the puppeteer, Henry must be aware of every move the roof makes. There is no room for error.
What I'm looking for is one that runs fast, one that's not moving at all, mostly. If one's not moving here, then that column's not moving. And this tells me which column it is that's not moving, and I can get one of my guys over walkie-talkie.
If he detects any problems, the system is shut down.
We can lock down anyone at any time and replace the cylinder, replace the hose, and then you have to repressure that guy and put him back in synchronization with everyone else. That's why it's real important that you can do one at a time or all of them at a time.
At 10 meters, Henry stops the lift. The roof has reached its new height.
Come on, this thing's heavy.
New steel beams are installed and the crib posts removed. After a few cosmetic changes, the building looks like new.
We've got the stability of it back. We have our column inserts all put back in, and job's over. It's time to go home.